Right, in this section we'll have a look at solving triangles, and we also have a look at what's called the angle of elevation and angle of depression. First of all, solving triangle. Well, what we mean by solving a triangle is that we have to find all remaining angles and all remaining side lengths. It's written up here. So in this particular triangle what we want to find is that side A and the angle A there, and also side B, the hypotenuse. That's written up here as well. Length A and B need to be found, and angle A needs to be found. Let's actually do this problem and solve this triangle. So here we've got the same triangle with the same angle size there, 25, and the same length there, 10. How do we go about it? Well, first of all, we can find the size of angle A, which must be 65 degrees, because those two angles must add up to 90 degrees. Then we have a look at the tangent ratio, because the tangent ratio is the opposite over the adjacent. If I call the adjacent A, I get tangent 25 equals 10 over A, and that can give me A equals 10 over the tangent of 25 by simple solution to an equation. In the calculator, 21.45. It remains then to find the hypotenuse, and of course we can use Pythagoras for that, and the answer there becomes 23.66 meters. Let's go into the second problem. Here we've got a triangle with two sides given, but we don't know anything about these angles. Again, we use trigonometry. First of all, we want to find the remaining side there by subtraction using Pythagoras. We get I squared equals 18 squared minus 12 squared, which becomes 180. Then I is the square root of that, 13.42, correct units, millimeters. How can we find one of the angles? Well, I've used the sine of angle P, which is opposite 12 over the hypotenuse 18, 0.6667. So we need to find the inverse sine of 0.6667, and on the calculator press shift sign to give me an angle of 41 degrees and 41.81 degrees. Then of course we know that angle Q must be the difference between that angle and 90 degrees, equals 48.19 degrees.